Okay, so here we are, section 1.4, question number 1. This, what they're asking me for, this one it will actually be pretty easy for you. They're giving me a point, let me make it bigger for you. They're giving me a point 15/17, comma 8/17. That's the x and the y, and they're basically asking me for all the trig functions. All the trig functions, sine, cosine, tangent, on and on you go. All of them. So, how do we do it? Well, what have we learned already about sine and cosine and everything? X is which one? Cosine or sine? Cosine. And y is sine. So if they want sine, see how the answer, these are the answers already there for you. See how the sine is just the y value? And the cosine is just the x value? There's nothing to do. Just write them down. Now, how do you get tangent, though? I want to remind you of... Yeah, for SOHCAHTOA, we're not using SOHCAHTOA right now, but for SOHCAHTOA, it's opposite over adjacent. What is it in terms of sine and cosine? Yeah, do you remember that it's sine over cosine? Have I said that? Okay, good. My 14-year-old is taking trigonometry at home right now. Next year he'll start coming here. We bring him over their sophomore year. But so he's doing trig. He's just watching my online doing trig. And last night I got home and he swore. He said, I couldn't find tangent anywhere, Dad. You never said tangent was sine over cosine. You never. That's why I'm asking. Did I say that? I said that. Anyway. So sine over cosine. So tangent is sine over cosine. So you just take sine 8/17 over cosine 15/17 like that, right? And then you grab the one in the bottom and you flip it up because it's dividing upside down, multiplying, right? So we just say, so take that 8/17, multiply by, grab that thing, flip it up like that. Let's give it a little flip. Am I going too quick? Is this making sense? So tangent, so you want to write that down, 3x5 card. Tangent is sine over cosine, becomes real handy. So then these cross cancel, it's 8/15, that's how they got 8/15. And the other three, flip it, right? For the other three, easy question. Now remember, you can only do that for a unit circle. And they did say unit circle, right? Cosine is the x, sine is the y on the unit circle. That's what we're going to have about 99% of the time, though. Every now and then, very rare, there'll probably one on the exam we take in a week, and I'll show you when we go over the practice exam next Tuesday. I'll say, hey, look at this problem. See, it's not unit circle, so we have to be a little careful here. Watch out for that. Here's how you'll recognize that on the real exam. I'll highlight it and talk about it. There'll probably just one that's not a unit circle, and I'll let you know the marks to watch for so you see it's a special one. Other than that, everything's unit circle. And then for the rest of the course, pretty much everything's unit circle. In good shape then. This will be easy for you. So see what they're doing? They're saying, okay, use this, or they're kind of like giving you the unit circle, which we've already been dealing with a lot. And they're saying, hey, what's the sine of 0? I've already got the answer there for you. What's the sine of 0? Well, like you already know how to use the unit circle, right? You just find 0 degrees, which is right here. This is really tiny. It's 1, 0. You know the cosine is the x and the sine is the y, so boom. Right. 0. We already know how to do that. These sections kind of overlap a lot, so that'll be cake. Okay? Everybody good with that? So they're just showing you the unit circle. They're emphasizing, again, use the unit circle. Cosine is always the x value. Sine is always the y value. They want sine, so it's the 0 at this spot, which is 0 degrees. Wait, that number was that number? Oops. Cosecant 2 pi over 3. All right, can you do that one? So go to your unit circle, right? You already know how to do that. Look at the unit circle. Yeah.
How do we access the unit circle that we have on?
Yeah, I put it up there. It's under announcements. Everything's there for you. So cosecant of 2 pi over 3. Go to the unit circle and look it up. So 2 pi over 3. Where's 2 pi over 3? Somewhere. Oh, there. 2 pi over 3 is right there. So cosine and sine, right? They're always out of order. Cosine's first, then sine. So cosine, sine. Cosecant, which one's that the upside down of? Sine. So you want to have that, if you don't have that down yet. That's upside down reciprocal is the formal math word of sine. So it would be, what was the sine? The sine is root 3 over 2. So it would be root 3 over 2, so 2 over root 3, huh? So upside down, like that. We can't leave a root on the bottom. What do we do?
Multiply by root 3 over root 3.
Multiply by root 3 over root 3. Done. Those are easy. You know this stuff already. All the hard stuff was in the last section. Good. Questions on that? X. So that's not anything hard. Just go to the unit circle, find 11 pi over 6. So let's go there. So 11 pi over 6 is, do you see it?
In the fourth quadrant.
Yeah, over here in the fourth quadrant, 11 pi over 6. Cosine sine. So sine, 11 pi over 6, minus a half. Good there. Go back, say, all right, minus a half. Easy question. But then part B is what I want to show you. They have negative 11 pi over 6. Now, I didn't write any negative, I didn't write it at all, but the one I got off the internet doesn't have any negative angles on it. So how are we going to find the sign of negative 11 pi over 6? Yeah, you just go backwards. So there's a couple of ways you could go. You could just go backwards that amount. I'm just going to put in 180 if that's helpful. You don't have to if you can just see it. Right? Let me give twist. If you could just look at it and go, look. So all the way forward to here is positive 11 pi over 6. That means almost all the way around except for one little jump. So then negative, start here, go down, right? Negative angles, we always start by going down. So go down. If you're going to go down 11 pi over 6, it must be all the way to there. Right? That's true. Want to just do that? You're right. That's it. Cosine sine, positive a half. Positive a half. Done. It's a mirrored image. Exactly what it is. Yeah. So if you're comfortable with that, great. If you want to change to 180 just to be sure, you could do that also. 11 times 180 over 6. Just plug in 180. This goes in there 30 times. It'd be minus 330 degrees. And then add 360 to make it positive, right? We can always add positive 30. Sure enough, positive 30. That is where it is. So if you want to be doubly, triply sure, you could just do that. Convert it to degrees. Now, there's actually one more way to know. And that, are they going to do it in this section? Okay, try that one. That's part B on number 14. It's the hardest one I could find in that section. See if you can find that. So you could put in the 180 if you want. Or you could just subtract a bunch of 2 pi's. Probably 180 is easier. So that'll become tangent of, I don't know. Yeah, 855. You know what to do. Subtract a bunch of 360s, right? Becomes a little more normal angle there. Subtract 360, subtract 360, I think twice. So 135 degrees. And then go to your favorite location, the unit circle. 135 degrees. Cosine sine. So the cosine is negative root 2 over 2. Sine is positive root 2 over 2. So how do I do the tangent? What are the tangent there? Sine over cosine, huh? Like we did a couple minutes ago. So you want to know that one, put that one in your 3x5 card. Tangent is sine over cosine. So sine, I'm kind of running out of room here. Let me bring it up. So it's sine over cosine, which is positive root 2 over 2 over negative root 2 over 2. What's that? Negative 1. Because it's the same thing over itself, but it's got a negative. It's negative 1. I mean, you could flip it up if you want, do all that, but everything's going to cancel. It's going to be negative 1. Tangent of that is negative 1. Yeah?
What would you do if it's a tangent pi? I mean, tangent 2 pi, or any of those. It lands on the 1 and the 0.
Yeah. So, yeah, we can do one of those. So, like, if you did tangent of pi, for example, yeah, we would just go to the unit circle. So, again, it's sine over cosine. Tangent is always sine over cosine. So, we just go to pi, find the sine and the cosine. So, let's go there. So, here's pi, cosine, sine. So, the cosine is negative 1, sine is 0. Bring it back. Cosine is negative 1, sine is 0. Good so far? Just grab those. So, now you need to know the rules about 0 being on the top or the bottom. What does it mean when 0 is in the top of a fraction? Just 0. What if the 0, now what if we did tangent of pi over 2, or let's just do 3 pi over 2, same thing. So we did 3 pi over 2, that would be sine 3 pi over 2 over cosine 3 over pi over 2. Let's go look that one up. 3 pi over 2 is right here. So, and so the cosine, sine, write those in, cosine, sine. Cosine 0, sine's negative 1, right? So, cosine's 0, sine's negative 1. Now, what does that equal? Undefined. That's undefined. Yeah, when you have 0 on the bottom, remember, 0 goes into anything infinite times. So that's actually undefined. So you got to be clear on that. 0 on the top is 0, 0 on the bottom is undefined. Underneath, undefined. Good on that? Okay, so there's number 15. They're saying sine, cosine, and maybe I better, it's a lot of writing there. So, sine of, what is it? Sine of t is A. Sine of t is A. Cosine of t is B. Tangent of t is C. And they want 8 sine negative t. 8 sine negative t minus sine t. Did I get it right? Yeah. Okay. So they want me to figure this out right here. And in terms of A, B, and C and stuff. So, yeah, so I need to write for you a special property for sine, cosine, and tangent. Here's the deal, and we'll give deeper reasons later. Sine of negative angle, if you put a negative angle into the sine function, it turns out that negative can just jump to the front. We'll give deeper reasons later. Tangent is the same way. Put a negative angle in there, it can just jump to the front. Which is super convenient. That way you never have to look up negative angles for sine or tangent. Does that make sense? So anytime, so if they gave me something like, find the sine of negative 30 degrees, I could just put that negative in the front and then just go look up the sine of regular 30. So I never have to actually look up negative 30 degrees. I just find regular 30 and the negative's in the front. Now, you might, I know when I was where you're at, taking math classes, just getting used to how math things work, that might look like, well, of course, but it's actually not of course. So yeah, let me help you think right about that. Because I used to look at things like that and go, why are they telling me that? Of course you can pull out the negative sign. I was naive and wrong. You can't always pull out negative signs. That's a special property, which is not always true. There's not some rule that says anytime a negative is plugged into a function, you can always bring it to the front. That's not true. So it's a special truth that you can do that for sine and tangent. Now for cosine, if they put a negative angle in there, you know what cosine does? Comes out as positive. In fact, it just completely vanishes. So cosine does something even a little stranger. It becomes positive. So that's a special rule. You can't just like always do that for any kind of functions in the math world. That's not always true. It's a special truth for these. So for sine and tangent, negatives plugged in come to the front. For cosine, the negative just vanishes. So somebody asked me, what's the cosine of negative 30 degrees? I just look up the cosine of regular 30. The negative is just gone. It just comes to the front and becomes positive. Does that make sense? I mean, I didn't give reasons for that. Later we'll talk about why. Why is such a weird thing true? But for now, let's just get used to using that fact. So when they ask me this question now and they put a negative in there, that's why I'm telling you about this, because we need that now. They put that negative in there. What am I going to do with that negative? Pull it to the front, right? For sine and for tangent, you pull it to the front. It becomes minus 8 sine of regular t minus sine t. Good so far? So I just pull that. Otherwise, I would have no way to do this problem. So I pull that negative to the front. And now, what is sine of t? What did they say it is? A. They're just playing a naming game up there. I don't know why they're doing it. They're just, it's like if I said, hey, that dog, I'm going to name you Rover. You know, they're just giving a name to sine. Literally just giving it a name. They're saying, hey, anywhere we see sine t, call it A. Call it Rover. They're just giving it a name. So when you see sine t here, you say, oh, he's A. We're calling him A. And this other sine t, yeah, he's A also. That's all they're doing. And so what's minus 8a minus A? Minus 9a, because that's a 1, huh? Done. Did you track with that? So the sign on the inside, the negative on the inside comes out. And then you just do the naming game. Sine of t, they said name an A. That's all that's going on there. Let's try. So number 17, they're going A is sine t. They're playing the naming game. B is cosine t. C is tangent t. And then they're going to go sine of 4 pi plus t minus cosine of 6 pi plus t plus tangent 7 pi plus t. I think, if I got that right. Wait, sorry, let me double check.
16.
Oh, is that 16? I didn't look at the number. So let me fix that. This is number 16. Okay, yeah. So first off, they're playing the naming game again. You know, they're going to call sine is A, cosine is B, tangent is C. But okay, now what's with this 4 pi thing? How do I do 4 pi plus t? What if I said, hey guys, the sine of, I'll just make up an angle, 2 degrees is 0.013. I have no idea what it is. I'm just making up. Let's say it's something like that. And then I said, hey, can you tell me, now that you know that, now that I'm telling you the sine of 2 degrees is 0.013, can you tell me what the sine of 362 degrees is? It's got to be the same thing. Why? Why would it have to be the same thing? How much bigger is it? How much bigger is 362 from 2? 360, one loop around, right? Remember the deal? If I'm facing that fire warning thing there, and I turn 360, what am I facing? The fire thing still, right? So if you have the sine of some angle, and you add a full loop, you're facing the same point. You're at the same location. Your sine, your cosine, your tangent, all of them got to be the same, don't they? So that makes sense. What if I'd added another 360? Which should be whatever that is, right? You see what they're doing? They're adding 4 pi. What's 4 pi? That's 2 pi and 2 pi. What's 2 pi? 360. That's all the way around twice. If I'm facing the fire thing and I spin around once, let me get dizzy here, and I spin around again, I'm still facing the fire thing, right? So if they add 4 pi, they're saying that's the same as sine t, right? The t is all that matters. Adding 2 loops does nothing, right? See what they're checking? They're checking if you're clear with that. Adding 4 pi is 2 pi, 2 pi. 2 pi is all the way around, right? Remember, pi is 180, halfway. 2 pi is all the way around 360. So 2 pi is 2 full loops. Added to t, whoops, I just erased it. Added to t, it's just going to be wherever you were facing with t. If you're facing t and you add 4 pi, you're still facing t in the end, right? And same thing with the cosine. What is 6 pi? 3 full loops, 3 2 pi's, whatever. It's just t, right? It's t, I'm facing t, and then I added 3 full loops. Well, you're facing t again, right? Now, what about this one? This one's a little trickier. Tangent. 7 pi is not full loops. It's 3.5, actually, full loops. It's 6 pi and then another pi. Well, it turns out they're hinting at a special rule for tangent. Tangent repeats, well, here, let me write. Sine and cosine repeat how often? Repeat every 360 or 2 pi. That you know, right? Every 360 degrees all the way around, or 2 pi in radians, sine and cosine repeat all their values, right? If you have some kind of sine or cosine value and you add a full loop, same place. Tangent, it turns out, repeats even more frequently than that. Every 180 or pi, only halfway around, and tangent starts repeating. That's called his period. We'll get more formal about that later, like next week, or maybe the week after. We have our exam next week. Week after next, we'll talk more formally about the period of the various trig functions, which means how long till they begin repeating their values. Sine and cosine, their period is 2 pi. They do their whole story in 2 pi, and then they repeat their whole story. Tangent, he does his whole story in just pi, just 180. And then he repeats his story every 180. So that means when you see 7 pi, that's 7 repeats of his story. So that also is just going to be tangent of t. They're just giving you a fancy way to say, look, you can just make all those t's, because the stuff we're adding is just repeating the story. So when all that is said and done, what is sine of t? They said call it a. And what is cosine of t? They said call it b. And what is tangent of t? They said call it c. A minus b plus c is the answer to that question. That's a little weird, but does that make sense? They're testing if you know about the full loop stuff. Just look at 17 with me for a second. They're doing, can you even see 17? Here, let me make it valid. So, all right, so there's number 17. I already got the answer there for you. It's the same game. It's the same game. Cosine of t is b, right? That's b. That's the naming game. Cosine, what's that 3200 pi going to be? A bunch of extra rotations that in the end do nothing, right? So it's just going to be cosine of t. It's just going to be another b minus. See what I'm saying? Yeah.
Is it always going to be that straightforward, or will...
For now.
Okay.
For now. Tangent of t, that's just going to be c. Tangent of that, that's a bunch of extra half rotations. That's just c again. Sine of t, that's a. Plus, am I off the screen there? 7 sine, minus whatever, it's just backwards rotations. Who cares? It's just a again.
Would it be 7A?
Oh, thank you. Thank you. I thought, where'd the 6 come from? Yeah, I was exactly wondering that right then, like how they were going to get that 6. But now I see, that's a 7a. Minus 1a gives 6a, doesn't it? Mm-hmm. Exactly. And b makes the 2b, and minus c minus 2c. That's all they're doing. Those are all just extra rotations that change nothing. All right, let's do 18. Part B. Okay, so this is like a little biorhythm problem, and they want us to, anyway, you don't have to read all those words, blah, 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 blah. All you need is that formula and plug in your t values. So I'm going to do that. So I'm going to plug in my t value right here. So this will be sine of pi over 14 times 49. Good so far? All you got to do is plug into that formula. And what will that equal? Well, I would reduce that right there. I would say, remember when a whole number is interacting with a fraction, put it over 1, cross, well, what goes into 14 and 49? 7. Yeah, divide them both by 7. That would leave sine of 7 pi over 2, huh? Right, good, 7 pi. Now, 7 pi over 2, that's not on my unit circle, because that's more than 360. If you wanted to stick in 180 for pi, you could do that now. So that would be sine of 7 times 180 over 2, which is sine of 630 degrees. And so then just subtract the 360, same thing as usual. What is that? 270, I believe, sine 270. Go to the unit circle, wherever that is, sine of 270. Where's my unit circle? I don't know, I've lost it. So I'm going to have to find it here. Sine of 270, it's -1, but let's see it. So sine 270, down here 270, cosine sine. Cosine sine, sine is -1. There we go. That's all we're doing with those parts. Does that make sense? Second one's the same. I'm not going to do it. Is that good? Is that making